continue straight from previous video. Now we are looking at external pressure coefficient for roof. In the previous video we found the external pressure coefficient for windward wall and leeward wall. Now we are looking for the external coefficient for the case of roof. Now for the case of roof, we are going to use three tables. I can show it here. Table number 5.3a on the page number 34. Table number 5.3b on page number 35, and table number 5.3c on page number 35. So there are three tables to find the external pressure coefficient for roof. Now I can distinguish between those tables. So 5.3a can be used for the upward slope roof, downward slope roof, and this R is the crosswind roof slope. So if you need the notation for those upwards, downwards, and the R, the notation is given here, and you can identify what kind of roof that we are looking for. In our case we have upward roof and downward roof, so that's what our case is. So these tables can be used for the cases where you have upward slope, downward slope, and or the R, which is a crosswind roof. So for example, table 5.3 can be used here, or with the R that has a crosswind roof slope. So these tables can be used for those cases. Table number 5.3b, that is the second case where you have table 5.3b, that is on page number 35, where you can use it for upward slope only and for alpha equal to greater than 10 degrees. So if I can show it here, only the cases where you have upward slope and this alpha value should be greater than 10 degree, you can use it, table 5.3b. And the last table is given 5.3c, where it says that downward slope and R, that is a cross wind roof slope, so greater than 10 degrees. So all the hip roofs you can use it is table 5.3c, and the condition is alpha should be greater than 10 degrees. Okay, so it's a descriptive, but you need to use this figure number 5.2 to get an idea what is the upward slope, downward slope, or the crosswind roof slope. Now for our case, we can identify here that in our case we can use 5.3a. Why we can use 5.3a? Because we have a downward slope, upward slope, and the alpha value also greater than 10, because in our questions alpha roof pitch alpha value is given 7.5, and if you want to look at that one, you can say that alpha value here, which is roof pitch, is less than 10, which is 7.5 in our case. So I already put here, we have alpha 7.5 less than 10. So we need some information here. We need to identify what roof we have. So roof type and slope. So I wrote roof type and roof type and slope, which is upward slope, downward slope. That is upward slope and downward slope. So we have here we have upward slope and downward slope, and the alpha is less than 10, which is 7.5 here, so no problem. Now horizontal distance, I will explain it in soon, but we can find out h on d. What is the value of h on d? So the h on d is the height of the roof, which is 5.5 meters over d is 16 meters. I can explain this one. Height 5.5 meters we calculated in our first video, where we have calculated the height of the building 5.5 meters. That is the height of the building, 5.5 meters we calculated. So that height is 5.5 meters. Now this d is this 16 meters. How can we identify that d? I think I explained in my previous video, but I repeat again. Now that d, in this case, for example here, when the wind is blowing from this side, the parallel edge, like the length of this side wall, is your d. So if you are typically compare these two cases here, wind is coming from this end, we have a 16 meters as a d. So that is d. So 5.5 over 16 give us 0.3, which is less than 0.5, and that is the case for our slope. That is our case for h on d less than or equal to 0.5. So we're going to use these values. Now for this case I need to draw a small diagram here to explain how the now we can draw the finding the CPE value for roof. We can draw this 16 meters of scale, so I'm just using the same 16 meters here, that is taken from this I'm drawing this 1, 2, 3 and 4 lines, so that is 16 meters here if I'm looking from this end. So that is 16 meters, and the 5 meters height of this edge that is given in the question, so that is just 5 meters here from this, and in the middle we have about here 8 meters, so we can draw this roof here 8 meters, and then another one is here. Now here we are going to divide this whole 16 meters into various sections for the roof particularly. So in the first sections, using the table number 5.3a, we can see 0 to 0.5 h, 0.5 to 1 h, 1 h to 2 h. So h is 5.5 meters, so 5.5 meters times 2 is 11, and here 5.5 times 3 it give us 5.5 times 3 give us 16.5. so total distance is 16. So we're going to stop it here. So we need to make it 1, 2, 3 and 4 and those sections here. So first section is between 0 to 0.5, second section is 0.5 to 1, third section is 1.5 to 2h, and the fourth section is 2h to 3h. So we're going to looking for a 4 sections here. So in this case we can have a first one, let's say from here to 2.8, second one is 5.5, third one is 11, and the last one is 16. So if I can just quickly draw it here. Now the first one is between 0 to 0.5 h. Why is that? Because the wind is coming, and then it says that this is because the horizontal distance from windward edge of the roof. So we need to start from the windward edge. This is the start of windward edge, and the wind is blowing from this end, so this become windward wall, and we need to start from windward wall. That's what given in the Australian standard. So if I substitute h 5.5, it gives us 2.75 meters here. Similarly, the second section between start from 0.5 to 1 h, so that's 1 h here, and that 1 h, if I substitute h equal to 5.5, so it gives 5.5 meters. Third section is between 1 h to 2 h, so that third section is 1 h to 2 h, that is gives 11. 2 times 5.5 is 11, and the last one is 16 meters. That's for this section for the roof, finding the CPE value. Now the first section between 0 to 0.5 CPE value is minus 0.9 to minus 0.4. So from this portion to these portions we have a minus 0.9 to minus 0.4. Second section from 0.5 to 1 h, it also has the same value. So second section same value, which is minus 0.9 to minus 0.4. The third sections, it has 1 h to 2 h, which has a value of minus 0.5 to 0. So third section is here, and is a little bit smaller, so minus 0.5 to 0, and that third section stop here, so that has a minus 0.5 to 0, and the last one is 2h to 3h, which is minus 0.3 and 0.1, so that has a minus 0.3 and 0.1. So that is the case of the roof. We just divided them into the different CPE value depending on the distance from the windward wall. Now we can also put the CPE value for windward wall, which is positive 0.7. We previously calculated that CPE value for windward wall in the previous sections. Previous steps, we calculate CPE value for windward wall is positive 0.7, and we also calculate for leeward wall, which is minus 0.5. So in here, which is minus 0.5. So this diagram shows the CPE value for windward wall, leeward wall, roof, and then the roof. Please note the roof is vary the CPE value as the distance vary from windward wall towards the leeward wall. Thank you very much.